Now we're going to take these concepts of linear programming and we're going to apply them to real life. And more often than not, it applies to businesses, okay? So this first example is going to involve making a profit. And so is the second one. But sometimes they involve minimizing the cost that they want to spend on something. And so I will give you an example of one of those as well. But let's start with this first one. So this first one says craft toy wagons are made to sell at a craft fair. It takes 4 hours to make a small wagon and 6 hours to make a large wagon. The owner of the craft booth will make a profit of $12 for a small wagon and $20 for a large wagon. The craft booth owner has no more than 60 hours available to make wagons and wants to have at least 6 small wagons to sell. How many of each size should be made to maximize the profit? So, what we want to do on these is we want to take this information and we want to convert it. First of all, we want to get an objective function. Okay? We want to know what is this, what are we trying to maximize? Well, obviously we're trying to maximize the profit. The two numbers that refer to money are this one and this one. Now, one thing we should do is identify what my X is and what my Y is. So up here, I'm going to just do it in the order it appears. It's best to always do it in the order that it comes up the first time, okay? You can see that the very first time that a mention is made of the wagons is here. Small wagon comes first, large wagon comes second, okay? So I'm going to make X be the small and Y be the large. Okay? So now I'm going to write my objective function. Okay? So I'm just going to write objective function. The objective function is what I am trying to maximize. I am trying to maximize his profit. Profit is mentioned in this sentence here, so I just have to apply it. The profit, P, is equal to, okay, how does he make his profit? Well, he makes his profit by selling some small wagons and some large wagons. The small wagons are going to be $12 each for the profit when they're sold, and the large wagons are going to be $20 each when they are sold. So the $12 goes with the X, so 12X, and the 20 goes with the large, 20Y. We will come back to this function at the end when we are ready to go ahead and plot in the points, okay? So the most important step after that is your constraints, okay? And remember, the constraints are your limitations, okay? What is limiting this person, okay, the owner, from making his profit, okay? So the other numbers are usually part of the constraints, okay? There is usually one sentence or one part of the constraints that has to do with making all of them together, okay? And so it says right here, it takes 4 hours to make a small and 6 hours to make a large. And then it says down here, he has no more than 60 hours available, meaning he doesn't have enough time to make to spend any more than 60 hours to make it, okay? We don't know if that's for a week or a month, it doesn't matter, okay? But the point is, that's his limitation. His limitation or his constraint is his time, okay? So the first constraint is going to be that the total amount of time it takes to make the small wagons and the total amount of time it takes to make the large wagons cannot exceed 60 hours. So 4 hours per small wagon is 4X plus 6 hours per large wagon is 6Y. That amount together cannot be any more than 60 hours. So those two together have to be less than or equal to 60. There's your first constraint. So now I'm going to put it into slope-intercept form so I can graph it, and then I'll find the other constraints, okay? So I'm going to subtract the 4X. I get 6Y is greater than or equal to negative 4x plus 60. And I'll divide by 6. And I get y is less than or equal to, this reduces to negative 2/3, the fraction reduces, plus 10. Now, it looks as if we have plenty of room to do this graph. However, when we start to graph it, we're going to find that the actual intersection is way over here off the graph. You wouldn't know that until you started. I'm just telling you that. I haven't given you any on your homework or your test that's going to do that, okay? But because I already know that, I have made the determination that I am going to represent each one of these lines as counting by 2s, okay? So this is going to be 2, I'm not even going to fill in 4, 6, 8, 10, 12, 14, 14, 16, 18, okay? I'm just going to kind of do it that way because I don't have enough room to really write in all the numbers and squeeze them in, but just know that every line represents 2, okay? And the same thing this way, so 2, 4, 6, 8, 10, 12, 14, keeps doing that, 14, 16, 18, 20, okay? All right, so if I'm going to graph this one, 10 is right here. So I'm going to put that on the y-axis. And then the slope is negative 2/3. And it doesn't matter that we're counting by 2s. You can still make the slope be the same. You're just counting negative 2/3. If I went down 2, technically that's negative 4/6. Doesn't really matter because it's still going to be equivalent because they're equivalent fractions. So down 2 to the right 3, down 2 to the right 3. Here, let me do this. Let me use a different color for that since I already labeled them. Down 2 to the right 3, down 2 to the right 3, down 2 to the right 3, up 2 to the left 3, up 2 to the left 3. All right, so let me go and plot in that line. Make the line a little less thicker. Okay, all right, so that's good right there. All right, so now you can see it says less than or equal to. Well, that means it's not going to be greater than, so it's not going to be above those lines anywhere. It's going to be in one of the areas below. Okay? All right, so now the only other number that is mentioned, I'm going to use a different color this time, the only other number that is mentioned in this problem is this. He wants to have at least 6 small wagons to sell. No restrictions on the number of large, but the number of small has to be at least 6. Well, the variable we use to represent small with is x. So the number of x wagons, the number of small wagons, has to be at least 6. That means it could be greater than or equal to 6. That is a vertical line because it's a vux. X is by itself. That's a vux line. So it's going to pass through 6 on the x-axis. So let me draw in that line as well. All right, now look what it says. Greater than that line. Well, if I'm looking at this vertical line, greater than would be to the right, not to the left. So already, I have eliminated now some more regions. Can't be this, can't be this, can't be this, can't be this. It's going to be over here somewhere, okay? Now, so does that mean this is our feasible region? Well, we don't know that unless we have made sure we've done all the regions. Well, we have, but how do we know if it goes all the way down here? Because we really don't have an end over here, right? Those have arrows on them. Or how do we know if it just goes right here? Well, that's where a little bit of common sense comes into play, okay? This is a real life example, right? In real life examples, he is going to make small wagons and large wagons. But the smallest amount of wagons he can make of either kind is 0. He can't make a negative number of wagons. So number 3 and number 4 kind of go together. The number of small wagons has to be at least 0 or higher because you can't make a negative amount. And the same thing for the large wagons. They have to be greater than or equal to 0. These are kind of understood. It is always understood that if we are using a real life example, then we are talking about an example in which you know that those are restricting your regions, right? So if this value right here is y is greater than or equal to 0, we know it has to be above and not below. There can never be a negative amount of anything made, okay? And then the same thing would be true for this one. That would actually be on the y-axis, a vertical line, VUX, going through 0. And of course, that means that none of the regions over here would make sense because you can't make a negative number of wagons. So again, that just further defines this side. And because of our y is greater than or equal to 0, we know it is above this x-axis. So that places our feasible region right in this area. Okay, so that helps us with our feasible region. So our last step then is going to be for us to find the vertices of that feasible region. So let's plug those in. Here's a vertice, here's a vertice, here's a vertice. So I'm going to list what those are, and then I'm going to plug each one in to our objective function up here. Okay, so one of them is obviously, let's see, 2, 4, that's 6, 0. This one here looks to be 6, 6. And this one here, ooh, that one's kind of hard to see. Hold on, let me get that off a little bit. Ooh, it doesn't look like it crosses exactly right there. Hang on. Let me see if I can get it. Can't really see it really well. But if you look, I kind of made this line a little low. It's actually supposed to be a little higher, which means it kind of crosses right here in the middle with that other line. So that right there is actually the point 15, 0. Yours won't be quite that difficult. You'll be able to clearly see where they intersect, okay? All right, so let's plug those into the objective function. Okay, the objective function, remember, is 12x plus 20y, and you can use a calculator. If this is x and this is y, then one possibility is 12 times 6 plus 20 times nothing, meaning he didn't make any large wagons. 12 times 6 is going to give you 72, and that would be $72. 6, 6 would place 6 in for both of the variables. This is going to be 72, and this one is going to be 12 times 6, 20 times 6, which is 120. 120 and 72 is $192. So obviously he's going to make more so far using this one, but we don't know about the last one. Then the last one is 12 times 15 small wagons and 0 large wagons. 12 times 15 is $180. So it's clear to see that he is going to make the most money if he sells 6 small wagons, and 6 large wagons. That will maximize his profit. So since he knows that, you can bet that he's going to go out of his way to make sure that all those sell, right? He knows, even if he has extra, he knows, or maybe he didn't bring extra, maybe he brought exactly this because he wanted to sell them all. But he's not going to, if he brings extra, and let's say he's already sold 6 small wagons, he's going to do his very best to get people to buy the 6 large wagons because he knows if they buy only small wagons, it's not going to maximize his profit, okay? So I'll do the second example in a separate video.